Thank you all so much for coming. This is your EXL 319, Planning Voice Features. I'm Jamie Stark. I'm a product manager in the Microsoft Lync team and have been for the last few years, and have had the pleasure of speaking at the last few TechEd Europes, and it's great to be back. Probably the single most important thing, though, that I have to say to everybody today is this slide, which kind of bothers me that they always change around our slides. I always put this up at the front, and they always move it to the back, and I'm like, no, I'm a speaker. I understand what I'm doing. Really, we want to make sure that this is valuable for you guys, not for us, not for our egos, but for you. And so the way that we do that is we have evaluations, and you guys go online and submit them and write comments and tell us, was this good? Was this bad? Too deep? Not deep enough? The whole 9 yards. We really do read these. I can speak for my team and all the speakers in the EXL track. We care about this stuff deeply. So submit feedback for everything, but if there's only one track that you're going to submit feedback on, please let it be ours. And just a little bit about what we're going to be doing when it comes to this session, and then just slightly more broadly, the kind of voice sessions here at TechEd Europe this year. So we have a ton to cover. And what I've decided to do is kind of think about it from two separate views. A view around the client and kind of features of the client, and then a view around the server and really where some of the features of the server reside. Server sessions on Friday. It's being presented by my good friend Mahendra. He's going to be going into things like interoperability and media bypass and how we work with PBX systems and resiliency and like all sorts of like really kind of big iron sort of stuff. I have the pleasure of going through kind of everything else with regard to voice, with the exception of really deep into dial plans, which is another session that we have a little bit later on this week. At the end of this, I've got a whole list of all the Lync-specific sessions. So if you're here to learn about Lync, I've got all the lists for you, you can take pictures of it and stuff at the end. And of course, we got our booth. I've got a bunch of demos that were almost affected by the network outage that we had earlier, because we have a VLAN set up between my workstation and our booth. And we actually bring out a whole infrastructure up and running with real live code. So we can show you guys not just what the client looks like, but also show you what the admin experience is like. And so that's the kind of extra piece that I want to bring into this session is, as we talk about features and as we talk about capabilities of Lync, specifically with regard to voice, we're going to then take a dive into what are some of the things as IT pros that you folks should be thinking about. So there's going to be stuff like bandwidth management. How do I think about policing my network? How do I think about wireless connectivity for a bunch of laptops and mobile devices running around that are going to be pushing out high-def video? How do I think about policy for end users and their voice features? How do I think about cases of particular devices? So there's going to be times in here where if you have some experience with Lync, you're going to be looking at this and going, I know all this stuff. Stick with me for a little bit, because then we're going to be getting into hopefully some of the things that you haven't had a chance to see before. And again, if this is good, if this is bad, if this is in between, whatever the case may be, please give us some feedback. The way that I like to think about voice features is really those 4 buckets underneath, and this is going to be the organizational structure that we use today. It's going to talk about, first, how do we connect together between Lync clients? Then how do Lync clients go and call out to the public switch phone network? It's kind of 2 separate sets of features. Then another set of features that deal with more enterprise class calling and management of phone calls. And then finally, a bunch of stuff into the network. And then we're going to go into things like call admission control and policy, DSCP, marking of packets and that sort of thing. So this is purposefully an attempt to be a fairly broad survey of capabilities with some depth in between. Does that all sound like something vaguely you're interested in hearing? please, just one little bit of audience feedback. Thank you so much. There will be one more opportunity for audience feedback where I will be giving away this wonderfully fancy Snom 370 phone, never been opened, never been touched, from our good friends at Snom who manufacture phones that work with many PBXs, including Lync. If you're a government employee and you're not allowed to accept gifts, then when it comes time for me to give this away by answering a question, please answer the question only in your mind so that my lawyers don't come and try to fire me as a result of violating some government policy. Anyway. So when we think about calling with Lync, I kind of then bucket link-to-link calling into three pieces. One, super easy to use, right? It's ridiculously easy to sit in front of a Lync client and to just make it function. There's a bunch of stuff that falls into that. There's a bunch of stuff that falls into not just being able to connect from any network, but being able to connect to nearly to any network. Right? As many networks as we can, we want to be able to federate to, and we want to be able to connect with. And then finally doing so with an audio and video experience that is really unparalleled. And that's both around some of the core media stack capabilities that we have, and it's around some of the usability features that we have as well. You know, so when I think about easy to use, I think that I can pick up my laptop and take it from the office and take it to a cafe, or I can take it into my house, or I can take it to my hotel here in Amsterdam, fire it up and connect it to the internet, and I don't have to do anything else as a result as a user. If I need to find somebody, it's super easy to be able to grab them and essentially do an extension camp on for all this old school PBX folks, which is tagging, but it gives me some presence facility along with that. Having not just redial, but having an extensive library of all my previous conversations that I can just one button click into and come back into a conference call or come back into an instant messaging session. I don't have to think about, wait, was that in my web conferencing product or was that on my phone? God, I just don't remember where all that stuff was. It's all in one place. Plus, it's available in Outlook, and I can go and search through it in Outlook as well. And then, of course, kind of basics like I can put the phone on hold and music is going to flow through to that end user. When I'm making my calls, I can make them between Lync environments, and I can also extend across the internet to other Lync environments. So if I have partners that are also running Lync, like Microsoft, you can federate with those other companies and effectively allow your edge servers, allow parts of infrastructure on your DMZ to be able to communicate with one another. We do this both with Lync deployments, and we do this with public IM networks like MSN, Windows Live, like Yahoo, like AOL. We also do this with XMPP networks as well. But there's some functionality difference that you're going to see. So effectively, when I'm federating with other Lync deployments, I get everything. So when I'm working with my partners, we're doing video calls. If I'm doing a presentation to Gartner, like Gartner has their conference bridge, their kind of official thing, and then they use Lync. And 9 times out of 10, we just say, screw it. I just want to do video. I just want to share some stuff with you. I am my Gartner analyst, and then we start talking. It's great. Same capability with Office 365 now. Office 365 can federate between tenants, can federate from tenants over to deployments. With Windows Live, we get audio and video. And then with AOL, Yahoo, and XMPP networks, we get instant messaging and presence capability. And the one notable exception on this list that you would expect to see but isn't here is Skype, of course, because we haven't announced anything yet with Skype, except that we're super excited to be able to work with Skype. We're working on it diligently, and unfortunately, I can't tell you what's coming, but it's coming very soon. I know. How many different ways can the Microsoft guys say nothing? Let's find out. Clearly, like, huge opportunity, right? And yeah, it's tremendous to be able to have all the business networks of Lync connecting with the massive consumer network of Skype. And so it's been a wonderful privilege to be able to be able to work on this and think about some of these scenarios. And yeah, it's absolutely coming. Don't have anything to announce yet. When we think about these modalities, the first thing that comes to mind, and many times the first questions that I get at the booth, literally today, one of the first questions I got in our booth was, tell me about the bandwidth. Bandwidth is actually an interesting and a little more sophisticated question. Because what we end up having is bandwidth utilization, first by modality, audio, video, desktop sharing, and then by what type of connectivity that you're using. So what this is designed to show, first, aren't numbers for planning. We're going to get to those. These are designed to show kind of how this all stacks up. And the way that it stacks up is all through the wonderful OSI model that we start with some raw audio energy that we're encoding into bits, and then we're going to wrap that around with some headers, then we're going to wrap that around some IP frames, we're going to wrap that around some Ethernet. And by the time all of that is said and done, when we talk about the fully loaded kind of set of bits for Lync, I guess that, oh, there it is. We're talking about this section right here, this payload, IP header, UDP, RTP, and SRTP. So the idea is that we are going to have kind of a raw number of, for example, G711 is 64 kilobits per second. You can literally do the math on G711 and say, I'm looking at the waveform this many times, I'm using this many bits per second, I'm going to get 64 kilobits per second of just audio energy. When that shows up on the wire with the payload and the IP header, it gets to be 80. When I get the security and some of the other pieces wrapped around that, it gets to be 92. And then you see for some of those other scenarios as well. There's a bunch of different bandwidth numbers around Lync. This is a way to kind of break it all apart so you guys can see where all this stuff is coming from. That last piece is forward error correction. It's a case where our media stack says, I've got a lot of bandwidth, but I'm losing a lot of packets. I'm on a really busy Wi-Fi network in the middle of a crazy technical event when everybody is on Wi-Fi. Got a lot of bandwidth, losing a lot of packets. In those cases, maybe we want to use forward error correction, which we actually send more bits, knowing that some of those bits are going to be lost, but by the time they get to the other side, I have lost fewer bits end to end. So it takes more bits, assuming that I'm going to lose some along the way. With video, that forward error correction piece is actually built into the codec. It's actually built into the video codec that we use. And so then with video, the question is less around scenario and a little bit more around what's the quality that you're expecting. There's 3 different levels of quality for peer-to-peer. For conferencing, it's typically going to be VGA or CIF quality video. There's not HD quality video in Lync 2010. But again, planning. Or I'm sorry, these are like raw numbers. When we get into planning, there's 2 pieces to think about. I don't expect you all to memorize this now. The first piece to think about is kind of what's my network like? In a case of a really well-planned, managed network, think about using the max bandwidth without FEC. What that does is that takes the codec numbers from the earlier slide and it adds 5 kilobits per second for RTCP, which is our checkpoint end-to-end to make sure that the network is up and running well. It tells us about network quality end-to-end. If the network is going to have some issues, you may want to think about planning using that forward error correction number. Oh, sorry, 5 kilobits per second for audio for RTCP, 10 kilobits per second for video with RTCP. When you want to just kind of think about bandwidth at a particular point in time, those end up being that typical column, but the typical column many times can be underserved. And so in some cases, you're going to want to think about that typical column less as a planning and more about what should I kind of expect at any given time on the network. From a planning perspective, where you don't want to run out, look at the max numbers. Application sharing functions a little bit differently because it's super bursty. Like if you're sharing a video over application sharing, that RDP stack that we use, we're going to suck all that up and try to spit it out the other side. And it's just going to go for it. Whereas if you're not sharing anything, if I'm sharing this PowerPoint presentation over desktop sharing or application sharing, it's not doing anything. So its usage is 0. So you find that it's super bursty. But what you can do is you can control those bursts. You can make sure that policy is applied to the end user system to say, I want my RDP traffic not to exceed a particular level. You got a bunch of ways that you can control this bandwidth. Right? We're going to talk about some of the ways to policy it across your wide area network with call admission control. We're going to talk about some ways to prioritize it with DSCP a little bit later when we get into the networking pieces. When we look at, if I just want to have a raw cap on what my client is doing, I can use these policies to say, I want to have an absolute maximum cap on my audio, my video, again, my application sharing and file transfer bitrate as well. So if you're concerned about a lot of file transfer traffic, then you have an opportunity to policy that as well. Similarly, with the MCU, with any conferencing scenarios, you can set policy to say, what is the quality of video that I want to be able to support by default in my video conferencing? Mentioned that RTCP traffic before, that's actually directly fed up into the client in that network health indicator there. Just like how your mobile device reads the antenna and says, hey, I got X amount of dB that I have signal strength. We're effectively doing the same thing in measuring these RTCP probes that go over the network. In addition to that, though, we're giving lots of great feedback to the end user. Feedback around what's their activity happening as they're speaking. That's their visual feedback that comes into the client. And I also have the capability to very, very simply move around what device my current call is on. And that's that USB device switching and optimization. We actually put a fair amount of engineering into this in the sense that we have a program with a bunch of device partners, a few of whom are actually here at the show as well. So go down to the booth, check them out. There's a few of them here. I think I definitely have talked to the Plantronics guys. They're out here. They got a whole suite of different devices. But effectively, we require from these guys not only that kind of great end user experience, but also an admin experience as well that gives IT pros some confidence that I can plug this thing in and it's going to work. Not only that it's actually going to be reporting this capability well back to any of my monitoring systems as well. So I want to actually show that a little bit. Yay, you can see it. So like I said, I've got a Lync client here connected with VLAN to Backstage, where we have a whole bunch of infrastructure. And what you can see is that right from within my client, I have the ability to choose what device I'm using. And so you can see I've got two devices. I've got one that's the default kind of audio and microphone and speakers that I've got from my workstation. And then I've got my headset. So if I go to start a call here, the audio test service, you're not going to hear anything, but I can just switch it midstream.
Then wait to hear how you sound.
And you can start hearing it. Hey, and this is Jamie, and I'm calling the audio test service to make sure that my audio connection is good.
Here's what I've heard.
Hey, and this is Jamie, and I'm calling the audio... God, I can't stand the sound of my own voice recorded. It's the one downside, but the benefit is that, right, I can see my default, I can change it midstream, I'm not putting the call on hold or doing anything goofy like that with multiple devices, and I've got the service that I can call as a user to make sure that everything's cool, everything's copacetic. So I'm going to pretend that my voice sounded so bad because I, instead of having a goofy voice recorded, that I didn't have a good enough microphone. So I just plugged in little Jabra kind of fancy speakerphone thing. Now, if I just make the call with this, you're not going to hear it so well. So let's go in and let's kind of change some of my defaults. And you can see that this is my audio device kind of test setup, right? So this is where users can go in if they need to make a little bit more detailed changes or they want to do some more detailed testing. You can actually go through and set this stuff up, right? So you see that my speakerphone, it's actually identified as a speakerphone. This was identified as a headset. That doesn't happen automatically. That needs to be engineered by both our device partners and ourselves, right, to make that work. What I'm going to do is set it up to where I'm going to go and change the speaker to be that, and I'll change the microphone to be the fancy echo canceling one from Jabra. So now I've got a custom setup. See, custom device, configured in audio device settings, right down there. So now let's see if it sounds any better. I know it won't, but I like to, fool myself. Oops. So that is check call quality.
To check your call quality, record a short message after the tone. Then wait to hear how you sound.
Boy, I hope this sounds better because the last one was, I was all goofy and stuff. Hello, testing.
Here's what I've heard.
Boy, I hope this sounds better because the last one was, I was all... No. So great for the end user, right? But I think the real benefit here is that with the end of every call, what we do is we will take all of the information that we get from the RTCP traffic, we get all the information about that current call, we package all that up, and we send it out to the monitoring server. The monitoring server has all the information about all the sessions that are going on in Lync world, right? So every client goes and sends this report up to the monitoring server, and you see that I just had 2 calls. It doesn't happen in real time because we want to get the totality of that call, so it happens right after the call is finished. So let's go see under the detail for this last call that we made. I see that all the details around the pool and who I called, which was this particular RTC application. It's an automated application that's running. And then when I look at the media quality report, I can see everything about my system, right? So how handy is this? Somebody calls up and says, I have really bad quality with a Lync. Well, why are you trying to run it on your old, 46DX66? It's probably not going to have enough CPU processing power to do that. I run Lync and it's great, but boy, sometimes it just, it just doesn't sound that good. Well, maybe if your capture device is the 50-cent headset that you bought for your kid and that you needed to use, at the last minute, it may not have the right, level of quality. It may not have very good drivers. So you can see that stuff just called out right there. In addition, all the little fiddly bits like microphone timestamp drift and all these other like really, really detailed parameters, you can actually, what'll happen is if this stuff goes out of spec, it actually gets highlighted for you. And then that highlighting comes back and actually shows up here in these details. So you see I've got some greens there and I've got some yellows as well. If a call fails, they'll show up as red and they'll get popped right to the top of the stack. So you as an administrator are going to have the ability to go and check it out. So not only are we looking after the end user to make it easy and to give them some configuration flexibility, you guys have the ability to come back in here and make sure that this stuff is actually happening as you would expect. Trust but verify, I guess, would be the way to kind of sum this up. So if you think about those all about kind of link-to-link, peer-to-peer calling and bandwidth and the way we think about devices. Now we're going to step into how we think about PSTN calling. And I'm going to look at this from a feature perspective. When we look at it from a dial plan, number normalization, egress route, all that sort of perspective, you're going to want to check out the deep dive on voice call routing. Thinking about it from an interoperability perspective, we have our planning for voice server-side session coming up as well. And again, 3 big buckets. PSTN dialing completely integrated. It's really easy to manage my calls. And in addition to that, I get great location awareness and the ability to make emergency calls as well. So PSTN dialing is just a standard feature of Lync. It's just a standard thing that we've built into the product. And then we expose it in a bunch of different ways. We expose it in Outlook. We expose it within the client as well. So the client has its own dial pad for folks that are used to using a dial pad for dialing instead of clicking on somebody's name. We expose it in Internet Explorer. So there's a bunch of different ways that anytime a phone number comes up in Internet Explorer, mash that button and go and fire up a call. It's really, really easy to manage my calls as well as an end user. So with like 1-2 clicks, I can be forwarding off to voicemail, simultaneously ringing my phone. In addition, Exchange Unified Messaging, the voicemail functionality that Lync uses is all in Exchange Unified Messaging. That product has a whole significant way of being able to manage phone calls as well. So when somebody drops into Unified Messaging, they can be presented with a prompt that says, hey, I'm out of the office. If you want to try to reach me on my cell phone, press 1. If you want to leave a voicemail now that I'll get in my email, you can press 2. Those types of things. You can even have that set up per time limits as well. So I had an example there of I want to have different kinds of call routing when I'm in my crazy 2-hour-long commute to and from work. The key about this, though, is that all this is really well policied on the server side. And we're going to get a chance to check this out in a demo here in just a second. But all these different features have the ability to be policied. And you can policy this, you can apply these policies from a group level, site level, all the way down to almost infinitize as a user level as well. In addition to policies for users, you also want to be thinking about policies for IP phones. And so there's going to be different requirements, whether those IP phones are phones that are expected to be used on somebody's desk, have one kind of set of policy, one set of features, and if those phones are going to be used as public devices. So do you want to have those phones, for example, automatically log on as a common area device? Do you want to have a timeout value there? So when somebody leaves that phone and they forget to log out, that it'll automatically log out and turn back into a common area device after a particular set of time. Do you want to have particular features that are going to be exposed on those common area phones? Those types of things. So Lync is going to provide you the capability to treat devices and clients separately and uniquely depending upon the particular use case. And then finally with kind of location and emergency services, there's just a bunch of pieces here. One of them is if somebody goofy is calling up your organization and threatening people, you want to be able to mash a button that says, hey, this is a malicious call, and alert IT to say, hey, this call, this particular DID came in at this time, and then you can start bringing that information to authorities. So that's exposed both on the IP phones and on the Lync client as well. In addition, we have a really robust emergency dialing capability. So both emergency dialing from the perspective of, in North America, being able to send location information along with the call. Here in Europe, we have the ability to, of course, have kind of normal emergency dialing. But one of the interesting things that we do with emergency dialing is that we actually base it on network location. And this is really handy where, if you think about it, you can have one site, one office being in Spain, that can have one set of emergency numbers going out. You can have another office in the UK with another set of emergency numbers going out, and another office in the US with another set of emergency numbers going out. And when somebody flies to Spain and arrives and they boot up their workstation, Lync is going to get that particular location policy that has that particular manner of emergency dialing. Similarly, when I'm in the US, same thing. What's cool about this is that we'll actually be able to also apply a mask to that, and I'll show it to you guys in a second. And the mask allows you to say, any phone number that you dial, I want you to treat as a local emergency call. So if you're in the US and you dial 112 or 999, both in common international, oh crap, there's something bad going on numbers, we'll normalize that down to 911 and place that call. Similarly, I hope that when I'd be out here in Europe and I'd have a stroke, the only number I can think of is 911, and I dial 911, and it's going to dial the correct number for Europe. So let's take a look at that. So now we're going to switch over to you guys see it? Cool. We're going to switch over to, this is the administrative console for Lync. So again, this is the real deal. In a sense, running in virtual machines, running downstairs in the booth. And we just have a single location policy here. I'm going to go and edit that. So in here we just have this single location policy, but the idea is that when I would arrive in a particular network, the network subnet, the network definition would have associated with it this policy. And so when the client gets this policy, then it's going to say, anytime that somebody dials 911, treat that as an emergency number. Anytime somebody dials 999, treat that as well as an emergency call, but instead dial out 911. And then if you're in the US and you have a hookup with one of the E911 service providers that we work with, then you would have this enhanced emergency services piece. And what that does is that actually takes the location of the user and it sends that along with the 911 call. And that would only work over a SIP connection. That's why we don't, and it's not yet available in Europe. Which is one of the reasons we don't talk about it deeply here at TechEd. Where does it get the location? In your site. So here in the site, so here we were having network problems earlier, so I didn't get a chance to build all this out completely. I apologize. But here is the one that I just started building out, the name, the region. My bandwidth and my location policy would be set here, and then you would see associated subnets down below, right? So I would define, whatever classy subnets that I have that would uniquely identify this Amsterdam location, and then associated with that would be the location policy that would then provide the emergency numbering for that particular call, or that particular site. So it's pretty cool. So it's the idea is that this stuff just is defined. This stuff is designed to kind of happen automatically, right? So you don't have to think about how location works from a 911 perspective, location works from a CAC perspective, location works from a bandwidth management perspective. We use the same location infrastructure, and we actually propagate that up to all of those different services. So the other piece that I wanted to talk about was voice policies. So I'm going to bring up here, I've got a few different voice policies configured. My user from the previous set is named Dan. Let me actually bring up that user config first. I can do a search just here against all of my Lync users configured. Here's everybody that's named Dan in our setup. I think we got like 1,000 users set up into here. And I'm Dan P. When I click on Dan P, I get all the different information about Dan. So Dan's enabled for Lync. He's got enterprise voice set as his telephony mode. You see his line URI. And then voice policy right down here at the bottom. So again, if I create users, I can just have them applied to a particular class of voice policy, or I can have them applied to a default, or I can say Dan gets his own special, happy, privileged voice policy, which is a good thing. Because in voice policy, there are actually some things that are pretty useful for a particular user. What I'm going to do, because this takes a little bit of time to propagate to the system, what I'm going to do is I'm going to flip all those bits. I'm going to commit this up to the server. And then I'm going to let it cook for a little bit, and we can talk about these. Specifically. So call forwarding, simultaneous ringing of phones, no big surprise. One of the ones that's really handy is that bandwidth policy override. The idea is that if I'm policing my network with call admission control, there may be cases where all the bandwidth is being used. And so a user would get a response of, nope, there's not enough bandwidth, sorry, try your call again later. Well, that bandwidth policy override, super, super helpful if, your CEO, for example, or any of the other C-level crowd isn't too excited about being told that they can't make a phone call right now. Generals, colonels, other very, very important people typically like that. And so nice to be able to have that as a switch, not for the unwashed masses like us, but for the people whom many times we support. Things like call transfer, kind of standard stuff. PSTN reroute is another associated with call admission control, actually. One of the really cool things that we do, because we have the capability to go and egress out the PSTN and egress out Edge, is that we do have the facility, if we do know that the network has some issues, that we can take alternate routes. That's not something that most PBX systems or most unified communication systems have the facility to do. So I think I've danced enough. I think that the policy has cooked. You'll see, let me click right down here. You'll see right now, I don't have the simultaneous ringing setting. It does say forward calls, but it's just forwarding calls to voicemail. It's not forwarding calls outside my network to some other PSTN endpoint, right? So if I sign out, it's the best part of the demo. Because you know what? I don't know if it's going to sign back in. You kind of wait, and you kind of hold your fingers. And even if it does sign back in, hell, I don't know if it actually got the policy or not. It's one of the beautiful things of doing live demos in front of real people. Excellent. So it's signed back in. Whew. And then let's check out what the call forwarding settings look like. Woohoo, it worked. So it's not instant, right? So the client downloads upon sign-in all the policies that apply to it. Network, location, features. And that doesn't happen, that sign-in, sign-out process, that doesn't happen by default. You don't want to just automatically sign somebody out. You can if you want, but you don't do that by default. And so when someone's signed out and they sign back in, I re-download all that policy as I signed in, and then I get that refreshed, and now I have kind of the full capabilities of Lync. Even up here, I see my report a call capability. That's grayed out because I actually haven't made a call that is reportable yet. If I went out or I've received a call or I've made a call, and I would have the capability to have that turned on and to report a malicious call. Cool. Oh, sorry about that. I will not touch that wire again. All right. Moving on. Enterprise calling features. I'll admit this is a little bit artificial. Enterprises, not only do they need this stuff, but they also need all the other stuff as well. This is a little bit more around what are the advanced kind of call handling things that you're going to see typically in an enterprise, especially around how do I move calls around between multiple users, being able to do shared line appearance, being able to do delegation and making calls on behalf of others in my organization, being able to have really great IP phone experiences, and then also to be able to set up automatic call distribution around my environment. So as we go through these, Lync's got a ton of facility here. Not just kind of basic stuff like call parking, but the delegation and private line scenarios are really important for the executive, the kind of C-level crowd. So if I set somebody up as my delegate, any calls that come in to me can ring to them. They can ring immediately. They can ring to them only. They can ring after 15 or 10 seconds. Got lots of facility to be able to manage that. I can set up a whole private line as well to say that if I want to give out my kind of special phone number that doesn't ring out to my admin, that doesn't ring out to my delegate, I have that, and it rings directly to me. I have that facility. I can do shared lines. I can do team calling, which is like a group call pickup type scenarios. And then probably one of the cooler things is that I can actually use my Exchange calendar information to influence my call routing. That's the lower left-hand corner there. So if I only want to have my calls routed to my mobile device during my work hours that I have in Outlook, I can set that up. So I know, like, after 5, 6, 7 o'clock, I'm not going to get work calls anymore on my mobile device, which is a pretty handy thing. Couple specific points on a couple of the services here. We're going to go into a little bit of detail on some of these services. First, on Call Park. So when you go to park a call, there are certain clients that are going to have the facility to go and park those calls. Analog devices, for example, don't have the ability to go and park a call. But I can park a call using the rich client, using the attendant console, which we'll talk about in a little bit, and using the phones as well. But any of those clients plus common area phones, PBX devices, older clients from previous releases, they all can pick up parked calls off the Call Park service. And effectively, the Call Park service is just like that announcement application, that test application we called earlier. It's a media service that runs on the Lync servers that's there to be able to accept a call, hang on to it, and then be able to send back to the parker a particular number that's your orbit number. So as admins, you want to think about how to configure that orbit range. How many calls are generally going to be parked at any one time? Do I need to have a range of 50, or need to have a range of 500? Now again, these are all internal numbers. You don't assign these numbers to users. That would be a little off-putting to have all these parked calls show up on their endpoints. And you want to make sure that that there's enough to be able to support the capacity of your scenario. Couple things to remember: DIDs, like direct inbound dial numbers, don't have the capability to be set up as an orbit number. So orbit numbers are typically 4 3-digit long numbers that are returned back that says, hey, to pick up this call, dial 321 or dial 4428 or things like that. In the private line scenario, again, really, really cool feature. There are a couple caveats to be aware of when you configure private lines for your execs. One of the coolest is that this is still single URI, single Exchange mailbox, and so somebody calls your exec and they on their private line, it's still show up in their Outlook mailbox like they would expect. And they're still going to be able to park calls, or still going to be able to do call pickup. But they're going to be able to do simul-ring as well, but they're not going to be able to have delegation. Kind of the whole point of having a private line is that it's private. So if you have delegation configured on your user, so this user is having somebody else help them with their calling, somebody calls in the private line, it's not going to forward off to their admin or to their delegate. It's going to just ring to that endpoint. Couple things that are different. This private number dialing is only available for inbound calls. So there's not a facility to be able to mask or to be able to send almost as a pseudo-anonymous outbound DID with that private line. And then calls to that private line actually show up a little bit differently. So it's handy for the exec that they're going to see, like, oh, hey, this is my golfing buddy as opposed to my business partner who's calling me up. And so Toast is going to show differently, and it's going to be able to have a different ring as well. Phones. Bunch of good stuff on phones. I'm just going to jump to the detail slide. So there's effectively two kind of classes of devices that we talk about when we think about IP phones. The first class of IP phones are the ones that we call optimized for Microsoft Lync. And these actually run software that we create and that we go and deliver out to the phone manufacturers. So it's running our media stack. It's running our codecs. It's running all the kind of Lync guts effectively wrapped around into a phone environment. One of the cool things about these devices is that we get a lot of the same facility and a lot of the same functionality in the Lync Rich client we get in these optimized devices for Lync. So I actually get my Exchange calendar showing up on the phone. When I go to look at one of the calendar items, if that's a Lync meeting, then I can click on that meeting and it'll automatically join me into that conference call. I don't have to punch any pins or dial a DID or anything like that. I jump right in. And so we really talk about this as functionally kind of an information worker type of device. Doesn't mean the other devices aren't awesome for information workers too, but they really are kind of optimized around not just Lync, but also this kind of information worker experience. The other piece that these do is that they work with Lync, the rich client, over a USB connection. And so when a call comes in, I still get a toast and I can mash on the button and the call will get answered, but it will come off of my IP phone. If I then want to add video, if I then want to add a whiteboard share, I have the capability to do so because the phone and the Lync client actually work in conjunction with one another. So it's another kind of handy feature to think about. Probably the place where we've seen the greatest growth in devices, though, is around this class of devices that are tested with Lync. So these are phones that they're not running our actual Lync software, but because Lync is built on SIP, and ICE, and STUN, and TURN, and RTP, and TLS, and many, many, many more 3- and 4-letter acronyms that are all open industry standards. We have partners out there that can just plug into that. If they're facile with SIP, if they're good with the stack and with the capabilities, they can just plug right into that. And we've seen lots of devices come out here. Just recently, like within the last, I'd say 2 months, we've seen all these ones down at the bottom here come to play, both from Polycom and from SNOM, and there are a few others as well coming down in the pipeline. So typically these devices, instead of supporting the RT audio codec, which is a Microsoft codec, and that has a slightly higher computational complexity, they'll typically support the standard G.dot codec so they can run directly within DSP. Doesn't necessarily mean anything is bad about voice quality or anything like that, but they just don't have the same level of elasticity for working over the internet. But significantly greater range of styles. We'll never make a phone with that many buttons, but people need phones with that many buttons. And so SNOM brings those out to market. Polycom actually has the middle set, those, they call them on the slide, the SpectraLink devices, the Kirk devices. Those are DECT-based devices. And the DECT devices, they will register directly to Lync, and then they'll use the DECT wireless protocol between the phone and a base station. And so another kind of great solution, really, really handy for cases where we're going to have people moving around and need to have like a device that's kind of with them that uses a connectivity standard that's a little more robust than Wi-Fi. Kind of rounding out the enterprise calling features is a bunch of different ways that we can triage and treat calls, not from a personal perspective, which is what we saw from call forwarding and simultaneous ringing, delegation and team calling, but from a perspective of being able to handle whole mess of calls, whole mess of numbers. So any numbers, any DIDs that you have in your company that aren't assigned to an end user can be managed by an automated process, can be managed by an automated service that runs in Lync and plays a message that says, hey, the number you called isn't available. Do you want to go and move your call to an operator? Have a whole attendant console application for folks that really need to have high volume call processing. That lower left-hand corner is our attendant console that is really designed to be able to quickly move through and triage calls in an efficient manner. And then finally, we have a whole set of capabilities that we wrap around a name called response groups that deal with call treatment, call queuing, and call routing. So call treatment being, call comes in, do I want to play a prompt? Do I want to play music? Do I want to accept speech from that user? We support speech in 24 different languages. Do I want to be able to play automated prompts, or do I want to be able to play recorded prompts back to that user and have them enter in DTMF to find the queue? Think about press 1 for sales, press 2 for service, press 3 for support. Being able to have queuing, so to say, I'm going to take that call after I know where it's supposed to go. I'm going to put it into a queue. I'm going to think about overflow timers for that queue. I'm going to think about what happens if that queue expires, like an agent doesn't show up within 10 minutes. Do I hang out? Do I take them to a voicemail? Do I give them some options? Do I send them off to another flow, to another call treatment? And then having groups of agents that can be either informal, anybody in your organization, or specifically log into a particular group or a particular queue to be able to handle calls. This all comes for free with Lync. You don't have to buy any more call center licenses to be able to do this. It's really, really powerful stuff. But it's not a contact center substitute, right? So you got 500-seat, 1,000-seat call center. Don't run it on response groups. You're going to run it on all sorts of great partner stuff. We've got tons of partners who are building all sorts of really cool applications on top of Lync to do contact centers. With response groups, think about your hunt groups in your PBX. Think about your small ECD queues in your PBX. It's a really great solution for those. On the client side, couple interesting points to make. One is, the kind of best overall experience, of course, we think is using the rich client, using a headset. When you're working with, kind of some of the larger agents, some of the larger kind of groups of agents, makes sense to use these type phone devices, right? Because largely these are agents who are going to spend majority of their time on the phone. They can use optimized devices, tested devices like SNOM, and be able to have a really great experience. Because the optimized devices are really designed around kind of the information worker set, if they're going to be used in response groups, it's probably better to have them used for kind of casual agents. If you're really looking to optimize around call handling times, you're going to want to choose either the rich client or a tested device, because the phone edition clients aren't really optimized around that really fast call connection times. You can find 4 to 6 seconds is the standard for having calls connect to these response groups. So, funny thing, I actually was all set up to do, I thought I was all set up to do a demo of the Kirk wireless devices, the DECT devices, because DECT is really popular in Europe. I want to go and support my European audience. And so I brought out a bunch of stuff that looks like this. This, unfortunately, is the DECT device from the US. And I thought, that's fine. I'm not a dumb American. I know how this works. I get power plugs. I can have connectors. I don't need to have the special European DECT setup. And a couple people are laughing because they know where I'm going with this. Indeed, while that is the one from Europe, and that's the one from the US, Europe, US, Europe, US, Europe, I thought, I don't see what the problem is. Just so happens that the US one runs on the frequency range that is also used by GSM data. So if I had all this set up, now none of your phones would work, which, considering the network outage that we had, probably would make at least some of you very upset. So just found that out kind of at the last minute. Enough time to make pictures. We'll definitely have these up and running down in the booth by tomorrow at the worst. So instead of doing phones, let's talk about response groups. All right. Back in action again. All right, so we're back. You guys see it? Cool. So we are now back in the Lync server control panel. And just like I described, and I'm really happy that we have this laid out in this manner, because it just makes sense to me in terms of the way that calls function, right? So I get calls, they come into my workflow, then from the workflow, I'm going to have them find a particular queue, and then from the queue, they're going to drop into a group of agents, right? So that's the way calls are going to egress in. When I think about configuring these, though, I typically think about inside out. So I think about first, what's my group of agents? So here I have my little IT help desk. My IT help desk is informal. I'm not going to make agents sign in specifically. When calls route to them, I'm going to have them alert for 20 seconds. I've got a bunch of different choices for routing method, and I'm going to talk about these just real briefly. So a bunch of these are going to be familiar. So, serial routing, call one, call the other, round robin. Attendant is actually one that's designed more for cases where you have attendant consoles configured, and you want to route to 3 or 4 people who are all running the attendant console or all handling calls. Because what attendant routing does is it presents them all at the same time, and it does so without any interest in presence. And so this can actually be handy if you're looking to do a slightly higher scale response group applications. One of the things that can limit some of the scale in response groups is that lookup into presence and being aware and informed of presence of your agents. So if you want to kick that up a little bit, you can use that attendant routing piece. And you see that my lowly vice president of sales, for some reason, happens to be set up as an agent in this particular group. Then for my queue, again, as we talked about having, first I'm going to define my group. And so I can have multiple different groups in here, and then I can have them arranged in a particular order, and so then it's going to fall through that order within the response group. And then finally, if my queue times out, what should I do? If my queue gets overflowed, if I have too many calls hitting this particular queue, do I want to fail over another queue? I want to take them out to a different task. And then inside that is going to be my workflow. Now the workflow is interesting. What it actually does is that opens up into a separate application that has a little bit more information that's going to be gathered from this application. So it opens up into a separate web page outside of the core Lync server utility. This is also handy because a lot of the changes that you make in here, you can actually have these pushed out to line of business owners. So the line of business owner says, hey, we're going to have, I'm going to take everybody out to the movies that's running this particular queue. I can actually go and change the call routing times by the business owner without having to involve IT, which is a pretty handy thing. One of the things to be aware of is right up here, this case of agent anonymity. It's a really handy feature where when somebody calls into a response group, by default, when they are connected to the agent, they're going to see the agent's name. They're going to actually see that, oh, I'm connected to this person. Well, you can actually configure that to say, instead of showing that they're connected to the name, they're showing that they're connected to just to the name of the response group. So this can be helpful for cases where you have HR or you have an IT organization. You don't want to have that particularly helpful IT guy always being pestered by all the users. So you can set up this by saying, hey, instead of having your calls to and from show up as you, they show up as the queue, which is good in some cases, but you'll notice some call modalities will be disabled. So let's look at actually what that means. So in this example, I've got a virtual machine. This is actually running the quality of experience on the left with a user signed into it. It's Diane. And then on the right is my client that's actually running local on my laptop. So I don't have any audio devices configured through this VM. I can interact with the client, but I actually can't spin up any audio sessions because I'm accessing this from within a virtual machine. So when I go in, I see Diane. and I have the capability to call, I can call for either myself here, or I can call on behalf of the IT help desk. This is called calling OBO, or calling on behalf of. You can either do it for response groups, or you can do it in the case of delegation. So if I manage calls for somebody else, the same functionality, the same capability is exposed. So let's call Diane on behalf of the IT help desk, and I'm going to mash Lync call. What I'm actually going to do, though, first is I'm just going to forward this call off to voicemail. So the call is going to roll in. See that the IT help desk is calling. I get my kind of standard set of stuff. I can go.
Please leave a message for Diane Prescott. After the tone, please.
And then I would leave that message as if it was the IT help desk. And you guys saw on that call window how the call said it was an anonymous call. It was called specifically for the IT help desk. So now some of the things that aren't supported when we do those calls are things that involve instant messaging, because we actually don't have the full knowledge of who's calling all the way through. So if I do this Lync call now, I'm going to have Diane, instead of just replying, reply with an instant message. Recipient chose to respond with an instant message, and oh, that's interesting. Typically, there shows an error up here in the client. But you heard the tritone that, or you heard the fast busy that now this call can't proceed, because we don't have the capability to have these voice call, to have IMs to be able to be sent through an anonymous facility. To do that, you'd want to spin up a bot or some other type of automated service. So that's what that means when we say response groups for doing that call on behalf of do have some limitations. And again, you can see call for IT help desk, and it's clearly labeled out as, hey, this is a call that I'm not sharing my, well, it's not completely anonymous. I'm not sharing my own personal call information with the user. Cool. Moving right along. A lot of the on-site networking piece we're going to be covering a little bit later on in the in TechEd. We're going to be getting to that shortly. So survivability, failover, some cases around PBX interoperability are all pieces that we're going to get into on Friday. One of the ones that I just wanted to cover really briefly that has been a topic of interest over the last year has been around networking, and specifically around wireless. And I wanted to let you guys know some of the work that we've been doing with some of our partners. Our goal here is to make sure that regardless of the network infrastructure that you have, you can have the tools and the capabilities to have a really great experience with that network infrastructure. So we work with a bunch of partners. One of which, specifically on the wireless side, is Aruba Networks. One of the things that we've been seeing with wireless is that more and more organizations are looking first to go with wireless, as opposed to having wireless be kind of an option or an alternate for a lot of their users. And we see lots of different trends happening within the industry, and we effectively think about breaking this down into 3 buckets. A bucket of being able to have just raw data over Wi-Fi, a bucket of being able to do real-time media with a stationary laptop, and then being able to do real-time media where I'm moving around the organization, where literally my session is going to be moving from access point to access point as I move around the building. And one of the things that we found with Aruba specifically is that pretty significant improvement over what you can find with other vendors with Cisco. I love you guys are taking pictures, but I promise all of these are posted on the thing. So feel free to keep taking pictures. It's all good, but you just don't have to. Anyway, Aruba's got a ton of information around how they actually are able to do some of this facility. What's interesting is that they actually can look into the specific RTP traffic that gets generated end to end. And by the nature of the way that RTP traffic is set up, they can identify that this is a Lync audio call versus a Lync video call, which they typically wouldn't have the ability to do so because all of our signaling and all of our media is all encrypted. And they wouldn't actually be able to tell what's going on inside that encrypted message. So they actually use some heuristics to be able to tell the difference between if it's just data or if it's audio or if it's video, and then prioritize that appropriately. And so we've done a ton of work with them. They've published a bunch of information around what are some kind of best practices for deploying unified communications with wireless. I know this is a super quick survey, and I'm more than happy to go into it in greater depth down at the booth. But one of the pieces I'm going to have to unfortunately skip through CAC. One of the pieces I wanted to get to was marking packets in DSCP. So I've got to give away this phone, and there's an interesting question coming up. So get ready. Anytime that we put packets down onto the network, we have the capability to specifically mark those packets based on where that traffic, what type of modality that traffic is, right? This is a really, really common configuration for folks that already have IP-PBXs deployed. If you have a Cisco network, if you have a Avaya PBX network, very, very common that all the traffic that those IP phones are putting out are all going to be marked as DSCP level 46 in the EF or expedited forwarding queue within your router. The idea is that when the router has contention for resources, it's going to prioritize traffic that has this differentiated marking over other traffic. And so one of the kind of canonical ways to think about this is to think about audio kind of having the highest priority because it's the least resilient in the sense that we're going to definitely hear if there's any glitches in the audio. Whereas we're a little bit more forgiving when it comes to glitches in video. If we lose a frame, maybe that frame isn't a key frame. Maybe that frame's just an interstitial frame, and we're not going to notice it quite as much. Whereas things like file transfer, app sharing, maybe we just throw that stuff into the bit bucket. One of the cool things about Lync, though, is that we're going to give you all the facility to be able to mark this and to be able to triage this traffic on your network however you need. So whether you have a very kind of built-out network infrastructure that uses DSCP today, or it's something that you want to implement, you want to be able to significantly manage that traffic in the future, we have the capability to fit into both of those models. In addition to be able to fit into the models of whether you have all the traffic marked at the endpoint, meaning my laptop, or you want to have the traffic being marked at the router. So in the case of having traffic being marked at the router, what you do is you want to separate out all the different traffic types into different port ranges, and then when the router sees that traffic comes in from that particular port range, and the router is going to mark it. This is a really common configuration, especially for network folks that just don't trust that damn endpoint. Because you know what? That endpoint could be compromised, and then all of a sudden somebody is downloading, BitTorrent traffic, and they're putting it in the EF queue, and it blows up our whole IP telephony system. That's not an uncommon set of thinking around the danger of kind of endpoints marking traffic on their own. So a lot of times what we'll find is that customers want to be able to do that at the ingress router level. We could totally support that. So we think about having separate port ranges for audio, video, signaling, application sharing, file transfer. And you want to be able to have this be both on the client side and on the server side. You have both to think about, right? Because RTP traffic is just one way. So it's from my client to the server, and then also from the server on back. So let's now look at that. So what I did is, before the network went all haywire, this is the one demo that I was like, it'd probably be a good idea if I actually had a backup. So I went and I took two screen captures, or two network captures. So this is Microsoft's beautiful and wonderful network monitor tool. Come on, load up. And so what I did is I fired up a test call and I clicked on record, fired up a test call, did my test call thing, and then clicked stop. And so this is the traffic that I captured as a result. And you can see, got all different kinds of traffic. I got TLS negotiations and stun and turn stuff. I mean, there's just a bunch here. But it's actually pretty straightforward that I see some traffic that's going from my client to the server. It's RTP. My payload's audio. It's running this codec. G722 because I'm talking to this automated service, so the service is running. So cool, like this is a relevant piece of data. And then what I can do is I can dive into all the details around this particular frame. And one of those details is this differentiated services code point, DSCP value. So this is part of the IP header, right? This is built into the IP standard. It's not anything extra you have to add in. The bits will be 0 if you don't set it anyway, and you can see that it's set to 0. The way that you set this within Windows is actually through group policy. So I go into my local group policy settings. I go through computer configuration, Windows settings, into policy-based quas, and there I see Lync high priority. You can kind of see all the different values there. So anything that's going to get matched to this Lync high priority policy is going to get the DSCP value of 46. And the way that I do that match is I say first, anything that comes from communicator.exe, which is the name of the Lync client, a little history there. And then any source and any destination and any set of ports. But in the case that I was talking about earlier, if you wanted to split apart audio, video, application sharing, you can have those all running on different ports as well, and having that apply to these different ranges as well in your policy. But then the damn thing wasn't working. I couldn't figure out why. So when it doesn't work and you want to know why, you want to know what's going on, don't trust anybody, go to the registry. So where do we find this in the registry? Is HKLM, software, policy, Microsoft, Windows, quas. And what I saw in there was actually those first two. Communicator client audio quas and Lync client audio quas. That both got pushed down by MSIT. Not Lync high priority. That wasn't in there. And then I remembered, oh, I didn't refresh my policy. So you need to run a GP update /force or reboot your system. When I rebooted, I see what you see now. I see both the MSIT policies in addition to the Lync high priority policy that I created locally. Now, of course, you can lock all this down. If you don't want any of your users to be messing with this stuff, it's all good. You can lock all this down if you want. But MSIT is nice enough to be able to have us be able to mess with this. They're still kind in that way. So then I ran the quas cap. So now I have quas enabled. I can see I want to go from, let's find some RTP. Cool. Uh-oh. I swear. Okay. For a phone with 58 seconds left in the session, I promise I won't make you late. Why does that say 0? Who said it first? Hey, there you go. You're absolutely right. And you get to come up and get a phone. Guy in the orange shirt. Yeah, that's right, because it's two ways. Because this is a packet that's going from the server to the client. I didn't actually set any policy on the server. I set the policy on the client. So let me find my client running RTP. Bam, there we go, DSCP 46. So it did work after all. Once I forced the policy, once I made sure that was in the registry, ran it again, it was all good. For the RTP stream that I set it for the one that goes from the client to the server. Also, if I was setting this up for real, I definitely want to be able to set it up from the server to the client. Just a couple other pieces that unfortunately I will not be able to go through. But in addition to submitting your evals, please take an opportunity to come and check out all the other Lync sessions that we have going on. You're right at the top there on Tuesday, Planning Voice Features. Deep dives into dial plans, and by when I say deep, I mean regex and all the other kind of goodness that comes with that. We're going to get into high availability and resiliency, edge, media connectivity, all that stun turn traffic that you saw in my network capture. You actually understand what that is. And then rounding out with planning voice deployments. It's going to be the mirror of this session, but more on the server side. And I am so sorry for keeping you 1 minute after. The welcome reception's going on right now. I'm happy to hang out for questions if you have any, but thank you guys so much, and welcome to TechEd.